All right, guys, today we'll be finding the roots from a quadratic graph. So the roots of a quadratic function are where the function crosses the x-axis and y equals 0. They can be found by factoring the function and solving for x when y is 0, as well as looking at the graph and seeing where they cross the x-axis. So find the roots of each quadratic function by graphing and factoring. So taking a look at number 1, we could factor this first. Think about when we set this equal to 0, how we solved it. So we know that the factors of 8 that have a sum of 6 are 4 and 2. So I can go through the process of factoring. It's x squared plus 4x plus 2x plus 8, group and group. So that's y equals x times x plus 4 plus 2 times x plus 4. So y equals x plus 4 and x plus 2. And remember, if I were to set those equal to 0, x plus 4 equals 0, I would get x equals negative 4. And if x plus 2 equals 0, I would get x equals negative 2. So we know those as the solutions, but they're also what's called the roots of the quadratic equation. So let's see what it looks like. If we pull up the equation, y equals x squared plus 6x plus 8. Pull up the table. We're going to look for the vertex, which is at negative 3, negative 1, because the negative 1 is sandwiched between the two zeros. And we'll graph some of those points. So I'm going to graph from negative 6 to 0 at least, so I see the curve. So negative 6, 8 is 2, 4, 6 to the left, and 8 up. Then negative 5, 3 is left 5, up 3. Negative 4, 0. Negative 2, 0. Oh, sorry, negative 3, 1. Negative 3, negative 1. Negative 2, 0. Negative 1, 3, and 0, 8. So here I wasn't given boundaries to graph over, so I'm going to put arrows on both ends. And there's my parabola. And if we look closely, what we're talking about here today is the roots. These are the roots. And we have negative 4 and negative 2, which are the same as the solutions that we found by factoring. So also just keep in mind, this is the vertex. It's a minimum. We can note the vertex as negative 3, negative 1, just for good practice. And as a reminder, the range would be y is greater than or equal to negative 1. Okay, so just make sure you're always thinking about those things, because those are the type of questions that you could be asked on a test or a Regents exam in relation to parabolas
Kyle
and
O'Flaherty, please report to the main office. Kyle O'Flaherty, please report to the main office.
quadratic functions. Okay, number 2. Same deal. We want to start by factoring. So we have a sum of negative 3. When we need the factors of negative 3 that make negative 2, and that would be negative 3 and positive 1. So we could break it down. Y equals x squared minus 3x plus 1x minus 3. Group and group. We get y equals x times x minus 3 plus 1 times x minus 3. So y equals x minus 3 times x plus 1. And if we were to solve these, x minus 3 would equal 0, and x plus 1 would equal 0. Adding 3 to both sides, x would be equal to 3. Subtracting 1 from both sides, x would be equal to negative 1. So those are the solutions, or the roots, and should be where our graph crosses the x-axis. So again, we pull up our table, y equals, clear what's there, x squared minus 2x minus 3. Pull up our table, and we want to look for the vertex, which I see here. And I know that once again because it's sandwiched between negative 3 and negative 3. So I'm going to graph from here to here to make it fit nicely. So negative 2 is at positive 5. Negative 1 is at 0. 0 is at negative 3. 1 is at negative 4. 2 is at negative 3. 3 is at 0. And 4 is back at 5. So again, I'm going to draw arrows on both sides because I wasn't told to draw it over a specific domain. So there's my parabola. And again, if I look closely, Okay, here's my one root at -1. Here's my second root at +3. So they match up with the solutions here. And note that they are the opposite of the factored form. So here when I have -3, that's telling me I have a root of +3. Here when I have +1, that's telling me I have a root of -1. Again, just for good practice, the vertex is a minimum at 1, -4, and the range is y is greater than or equal to -4. All right, let's keep on going. Number 3. So again, this time when I'm going to factor, it's not as easy because it's not a trinomial. So I'm going to look for a common monomial factor. My common monomial factor here would be 2 and x. So I take out 2x and I'm left with x minus 5. Okay, so I solve for these just like I would when I have two binomials. Dividing by 2 here, I get x equals 0. Adding 5 here, I get x equals 5. So that's telling me that my solutions or roots are 0 and 5, but let's graph it to be sure. So we pull up that same table, y equals 2x squared minus 10x. Oops, I did something wrong. Minus 10x. Okay, and now we look for our turning point, which in this case happens to be in between 2 and 3. Because of that -12, I don't see a number sandwiched in between. So I'm going to change my table setting so I see 0.5. And now if I look for that same point again, I see that -12.5 is my vertex. And I want to be able to graph some of these points around it. So I'm going to do, let's say, 0 to probably a little bit more because I can get some more of those points in there. So if we scroll up a little bit more, we can't fit -112. So let's start with -0.5 and 5.5. Actually, that doesn't fit either. So we're going to do 0, 0. Then we can do 1, -8. Then we can do 2, -12. Uh-oh. Let's change our scale here. Oh, this is not going to fit. So let's do 2, 4, 6, 8, 10, 12, 14, 16. That'll help it fit. And over in this direction can still be by the 1. So we've got, again, 0, 0. Then a half and -4.5 we won't worry about right now. 1 and -8 would be here. Then 2 and -12 is going to be here. And 3 and -12 is going to be here. Now it can't be flat there, so now we have to add in our 2.5 and 12.5 there. Then we are going to go back up 4 and -8. And then 5 back up to 0. So there we go. That's why we always do our work in pencil, so we can erase if we make a mistake. There's our parabola. Okay, and again, just like we found algebraically, our roots are 0 and 5 because they cross here and here. Keep in mind again that that's the opposite of what was in the binomial. All right, also for good practice, this is a minimum at negative or 2.5, -12.5. And the range is y is greater than or equal to -12.5. Okay, number 4. Again, we see a binomial. Okay, so it's not a trinomial that can be factored into a difference of two perfect squares. We have to think about this a little bit more. So now let's see if we can factor out that 1/4. That might help us. If we factor out the 1/4, we get y equals -1/4 times x squared, and then what times a fourth makes 9? That would be 36. It's like doing the reciprocal, so minus 36. And then that's a difference of two perfect squares, so that's y equals -1/4 times x minus 6, and then x plus 6. So then if I set these two equal to 0, x minus 6 equals 0, or x plus 6 equals 0, so x equals positive 6 or x equals negative 6. So positive 6 and negative 6 should be my roots, which is where I cross the x-axis. So let's pull up the table and see if we find the same thing. We pull up y equals, we do negative 1/4 x squared plus 9, second table. I'm going to get rid of these 0.5s just to see if it makes it a little bit easier for this one. And let's see if we can find the turning point. Oh, I found it. So right here, the 0, 9 is sandwiched in between the 8.75, so that is our vertex. And we can build our graph around it. We could do negative 6. Oh, we can't fit negative 6 on our graph. Why did I do that? Let's change this graph. So let's change our scales here so we can fit it all. Let's make this be -2, -4, and -6. And then over here, +2, +4, and +6, so we can fit everything on there. All right, so we can go from -6 to +6. Starting with -6, we have 0, 0. Then -5, I'm going to skip. I'm going to go to -4, that's at 5. Then -2 is at 8. Then 0 is at 9. Then 2 is at 8 again. 4 is at 5 again. And 6 is at 6 again. So there's my parabola. Again, whenever you're given a coordinate plane, if it doesn't fit the space you needed, you can always change the scales. All right, so in this case, I have a negative parabola, and my roots are showing up, okay, because I have +6 and -6 as my roots. Again, the opposite of the two numbers in the binomials. All right, in this case, I have a maximum at 0, 9. This should not have been there. It should have been here. Sorry about that. And a range of y is less than or equal to 9 because it's going to be getting smaller, not getting higher. All right. So hopefully this is making sense. You're now going to try numbers 5 and 6 on your own. I will be around to make sure that you're doing it correctly.